Okay, for an example, let's say we want to find the distance from the point 3, 1, 2 to the plane x minus 2y plus z equals 5. So I want to draw a picture first. Same picture that we had before. Here's the point P, and here's the point closest to it on the plane. Here's some other point, and I'm going to draw the normal vector coming off of there. Now, the length of this is the distance we want. So we're going to look at the vector from the point Q to P, and if we look at the projection of this onto the normal vector, it's going to project back to here and give us this vector here, which has the same length as the distance that we're looking for. Okay, so we've got P. We need to come up with Q. Q is going to be any vector x, y, z that makes this over here a true equation. So I'm just going to pick Q equals 5, 0, 0. That will satisfy the equation, so that's in the plane. And now what we need is the component of QP onto N, which is the same thing as the size of the projection of QP onto N. And that's QP dotted with N divided by the size of N. All right, so QP, we can work out what that is. QP, so that's going to be QP is going to be P minus Q, so that's going to be 3 minus 5 is negative 2, 1 minus 0, and then 2 minus 0. So I get 2, 1, negative 2, 1, 2, dotted with N. Now, N is the normal vector to the plane, which we can pull from here. So N is just 1, negative 2, 1. All of this is divided by the size of N. So the size of N is the square root of 1 squared plus 2 squared. Pen's not writing. 2 squared plus 1 squared. And so this dot product up top, oh, and it's the absolute value of this. So the dot product up top is going to be negative 2 minus 2 plus 2. And on bottom, we've got square root of 6. So this winds up being 2 over square root of 6. That's the distance from the point to the plane.